Today we're going to talk about the rock cycle and then igneous rocks right after that. First, based on your reading from last night, think about it. What is the most abundant type of mineral that we find on the earth? And why? What is the most abundant type of mineral that we find on the earth and why? See a few hands. You want to rock, paper, scissors?
It has to be a math person.
Okay, 10.
Silicon?
Is silicon a mineral? Why?
By volume, it makes the silicon and oxygen make up 98% of the earth.
Good job. You got it. Very nice. What are the two most abundant minerals? Ashley?
One of them is quartz,
Uh-huh.
and the other one is
One of them is quartz. Anybody else want to take a stab? Feldspar. Good. Nice job. Yeah, good job, guys. So the silicates are most common because silicon and oxygen compose about 90% of the Earth's mass. And potassium feldspar, specifically, of the feldspars and quartz, are the most common minerals. Okay, so here's an overview of the rock cycle. And you're going to see this illustration. We're going to refer back to this as we go through the rock cycle. You can start anywhere because it is a cycle. There's no beginning and no end because it's a cycle. So if we begin with the magma, this is the molten rock, the plastic asthenosphere. It comes up and cools and then becomes an igneous rock. Then several things can happen. It can be exposed to heat and pressure and it changes the crystal structures. So we call it a metamorphic rock because metamorphose is change. So this is a changed rock. If the igneous rock is weathered, eroded, and those pieces are deposited elsewhere, it turns into sediment and becomes a sedimentary rock, which can be weathered, eroded, and deposited and become part of another sedimentary rock, or it can be exposed to heat pressure, become a metamorphic rock. All of these can be subducted, melted, and back into magma, becoming an igneous rock. There's 1,000 different possibilities that a sediment can go through, or a molecule can go through in that cycle. So let's look at this. The rock cycle is just simply an illustration of the relationships between all the three different types of rocks. There's igneous, sedimentary, and metamorphic. If you say sedimentary, that's fine too. It doesn't really matter. Not sedentary, that's not the same thing. So these rock types are exposed to different processes. And we're going to look at weathering, erosion, and deposition as the processes that you're exposed to, as well as compaction, lithification, heat, and pressure. All of these things make those rocks what they are. Okay, so this whole rock cycle is just about the transfer of mass from one phase to another. This mass begins as in the plastic phase, and then it goes to the solid, and it's repositioned into something else, or restructured into something else. And it's been occurring since the beginning of the Earth, and it's always occurring. As long as this is occurring, our planet is dynamic and living. So we're gonna work on a graphic organizer, and my handout's got a little messed up, so y'all just hang tight while I tell you where to go in this handout. For example, page 1 is a mistake, so you can just scratch page 1 out and turn to page 2. Yes, scratch that page and go to turn the page, and you're going to look at this rock cycle illustration right here. Everybody have one? Okay, this is from a book called, it's a GEMS, G-E-M-S, it's called Stories in Stone. And this graphic is from there. Pencil. Okay, all set, okay? And part of this is already completed. So we're going to start with the 3 types of rocks in these 3 long bars. The beginning here at the top, it goes to erosion, then sediments, burial. What kind of rock do you think fits into this section right here? Sedimentary. So let's write that in. Okay, what type of rock? Let's see, so sedimentary rocks, then what we can put metamorphic here on the right. Which leaves igneous for the top. Metamorphic. Thank you. I did. Good job, Pam. Good job, people who caught it. Okay, so here's some processes. Erosion is the breaking up of the rock. I'm sorry, erosion is when the rocks are broken up, the sediments are transported, and then they're buried, and then they become sedimentary rocks. When sedimentary rocks are exposed to heat and pressure, it changes those minerals in the rock. It changes the minerals. They are compressed and heated, so there's recrystallization, and they can rearrange or even change into something else. And then we call it a metamorphic rock because it is changed. Now this heat and pressure process also can happen to igneous rocks. So igneous rocks can also become metamorphic rocks. So let's write heat and pressure up here as well. Yes, ma'am.
Is it incorrect to include weathering? Or, I mean, because I always see without weathering in the cycles. Or is
Yes,
it because
there's
it doesn't necessarily have
weathering,
to break?
erosion, and deposition, but that's, yes, absolutely. It's implied that it's in here. It has to weather before it can erode. Okay, so this outside ring gives us another option for these rocks. So let's start here with igneous. I see arrows coming to the igneous rocks. What do you suppose might go into these arrows and circles that look just like these? What do you think could be in there? Starting from sedimentary rocks, what will happen for this sedimentary rock to end up at the igneous rock line? Sedimentary rocks, what's going to happen to the sedimentary rock? What does any rock have to become before it becomes an igneous rock? It has to melt. So first, this sedimentary rock, there's melting that occurs and turns it into magma. Yes?
So, withering is the process of erosion?
No, and we're absolutely, don't stress out about knowing all the differences right now. Weathering is breaking it up, right? Erosion is moving it away. Deposition is putting it down. Think of wed. It's like marriage wed. You break it up, you move it,
Wait, what
and you
does that
put
have
it
to
down.
do?
Maybe that was a,
I don't think that was the best.
how about you mix it up?
You said wet.
And then you get all your stuff and you move in together and you put your stuff in the same house. Okay. So after the magma cools, crystallization occurs in minerals. So this sedimentary rock, it melts and it becomes magma. This magma cools and crystallizes into the different minerals to become an igneous rock. Now, if we are a metamorphic rock, how do you think this metamorphic rock eventually becomes an igneous rock?
Same thing.
Good, same thing. There's melting. There's magma, and there's crystallization. Now, are we done? We have some blanks here. So what can happen to this metamorphic rock? We know that the metamorphic rock can melt and be turned into an igneous rock. But the metamorphic rock, if exposed, what can happen to that? Well, it's already cool. It's just a rock sitting on the land. Okay, we can have weathering, erosion, and deposition. So we have, just like this igneous rock became a sedimentary rock, so does the metamorphic rock. There's weathering, erosion, and deposition. So first, the erosion transports the sediments, or the tiny pieces of rock, and these sediments are buried. Once these sediments are buried, long periods of time later, they are compacted and lithified, which means they become hard rocks. And we call those sedimentary rocks. So, is there anything else we might add on here? Can you think of anything else to add? I like that you brought up the weathering piece because it absolutely is there. Go ahead.
Oh, I was just curious about the time frame. I would like to know the timing of all of this. How long does it take?
Well, it could take, I mean, if there's if you have a rock structure, and you have some kind of magma intrusion, it might take a long time for that magma to cool. Like, depends on, I mean, there's rocks that depends on how quickly the heat can escape. How quickly, you know, some of those things, like if you have a volcano, as soon as that magma is erupted out of the top of the volcano, it's already crystallized. It crystallizes like that. So that's one thing we're going to look at today is igneous rocks and how they crystallize. And so that some of the processes are slow, some of them are quick. Some of that compaction of sediments can happen in 100 years if the conditions are right. Some of them, not at all. So, I mean, it depends is not a great answer, but it depends. Yes.
So I need clarification on this. Erosion is the process of weathering in deposition?
No,
No.
they're all
So-
processes.
So does it weather, and then erosion is the movement, and the
Yes.
deposition is the placement?
Yes.
So then you just put down erosion?
Yes, I did, just to shorten it.
Okay.
Okay,
Just,
so
so I was just
weathering-
making sure, yes.
Weathering
So
is
something like
breaking up.
which can be mechanical or chemical?
Huh?
Which can be mechanical or chemical, yes?
Exactly,
Okay.
yes.
And then
Erosion moves it.
erosion moves it,
Uh-huh.
okay?
Deposition
Is the
moves it
placement.
down.
So that would be like the deltas are formed by the deposition.
Exactly.
Thank you.
Yes.
So I'm going to-
When you go to the bank, you make a deposit. You put your money in the bank. When you're at work, you do your work, chemical or mechanical work, and you earn money, and you take those pieces of money to the bank. Your erosion is the moving of your money from your job to your bank, and then you deposit the money at the bank.
Sorry, I have to get them lost.
And if your money stays in the bank over large periods of time, then you will build that money up into stacks and stacks of layers of money that are
I can't use that
set
example of my
across.
bank account.
Is there more erosion happening here? Is that the problem?
Yeah, no, it's a temporary
Yeah.
account,
Okay.
it's the deposits and then it's
All right, so what we're going to do today is we're going to look at this rock cycle, which gave us, we illustrated how those, oh, this, can I show people this? This is so cool. She's a girl after my own heart. Isn't that beautiful? The 3 rocks are color-coded, the processes are color-coded. That is gorgeous. Thank you. So, first, we're going to look at all 3 of these rocks that we've illustrated on our rock cycle diagram. And we're going to look at those processes that changed them. And we're going to do that over the next few days. Not tomorrow or Sunday. We will continue on Monday, unless you just want to do it on your own. So first, before we get going, I want you to distribute your table tents for your roles, please. Okay, now, the materials manager, I'd like the materials manager to come forward, and I'm going to give you a hand sample of the rock.
Give us the best one.
That might be a stretch.
That it looks like everybody else.
My stuff looks like everyone else.
Okay, this rock sample that you have picked up is similar to this one. Have you seen this rock sample before? If you get out your hand lens, look at it, observe what's in it. Have you seen this rock before? Anybody else? I've got an extra. Okay. Mary Lou, have you seen this rock before? On your kitchen counter. Is this a rock or a mineral? Why is this a rock? Can you tell everybody?
Oh, it's a rock because it has more than one mineral inside.
This is a rock because it has more than one mineral inside. Thank you, that's really good. And how did you make that determination that it has more than one mineral?
Because there are lots of different colors or like, I would say luster to each one.
Okay.
So they're not all the same.
So even though we haven't named these minerals, you have observed that all of the different colors have different characteristics that you're just seeing with your eye. Thank you. Okay, now, turn to your handout. Yes, ma'am. Yes. Perfect, thank you. Now, Pam is gonna pull out her smart scope, thank you. Okay, so we're gonna look at this rock, but we've broken it down into pieces for you, and we're gonna do an exploration, an investigation called the minerals in granite. So this is your handout that you're going to look at. And materials managers are gonna come forward and get one plate, a dropper bottle for acid, and a petri dish with crushed granite in it. And goggles. The goggles are on.
And gloves. Or cast. Let's worry about your eyes though.